Welcome to Heavy Networking, the flagship podcast of the Packet Pushers Podcast Network. Jeremy Schulman joins us today in an in-person recording done at AutoCon Zero, the first conference devoted to network automation and put on by the Network Automation Forum. And if this is the first time you're hearing about NAF or AutoCon, you should check them out, networkautomation.forum. Now, just a couple of hours ago at AutoCon Zero, Jeremy delivered a talk from the main stage about delivering network assurance. And if the term network assurance doesn't mean anything to you, think about how you prove after an install or a change that the network is doing what it's supposed to be doing. And if you're doing it by hand, you would be doing a lot of logging into devices to see that routing adjacencies are what they should be and that there's reachability and so on. What if you could automate all of that? How would you do that? Where would you even start? Well, Jeremy's been working on this and related things for a number of years at Major League Baseball. He's got some answers for us. So, Jeremy, the title of your talk was Design-Driven Network Assurance. So I think we got to start there because in those four words, Design-Driven Network Assurance, that's a philosophy, it's an approach, it's how you handle this pretty significant problem. So talk us through what you mean by Design-Driven Network Assurance.
Sure. And thanks for having me on the show. Really great to see you guys in person. So when I look at the problems that network engineers, struggle with, they struggle with config, deployments, they struggle with operational management. I work with a team that is a network engineering and operations team. So they're not separate teams. They work together. And in order to look at the whole of the network, right, we have to understand what is it supposed to be doing. That is the design. So somebody said this network is being designed for a purpose. And in their minds, they have a certain set of expectations that if they configured it according to their design, then they should be able to log in and do all the show commands. And so what I learned through, my sales experiences, for 10 years was you can't take configs off a box and reverse engineer the intent of the networking team, because the configs could be, something that grew out over years and years and years. And there's no way to reverse engineer the intent of something based on all of that. So we had to rethink the approach as a whole. We just couldn't start with config automation, or we couldn't just start with just operational show commands in isolation. What I learned from my experience with Apstra is that you tie those things together inherently. And when you start with the design, then you can programmatically reason about, what the network is supposed to do, so you can generate the configs, and then from the design what needs to be validated on the network. So I'll stop there.
Okay, so the important piece here is we're starting with the design, as in forget what's out there. You've got switches and routers and they're cabled up and there's a topology. Forget that. Step back, look at the problem you're trying to solve. What does the network design look like that meets that goal, that business objective? That's the place we have to start with, something that is a sheet of paper, something modeled in the computer?
Yeah, so that's an interesting question, because at some point it could be as bad as there's no documentation whatsoever and you have to sit with Bob. And Bob knows how the network was built because Bob's been here for 10 years. And, and if you were to try to reverse engineer BGP policy by looking at configs, you would lose your mind. And then Bob would be like, 10 years ago when, the network was like this. And then, you listen to Bob's story. And so at some point, if you walk into a brownfield network and it's like that, then there is a rediscovery process where you really have to go back and go, all right, what is the design of this network? Because until you look at it, and then maybe you do have to draw those pictures. Maybe you do have to create those Google Docs to say, this is what it was supposed to be doing, even before you can even attempt automation. Because the design really is the path of where you're going. And if you don't know where you're going, then any path will take you there, as we know. And that's why a lot of automation never takes off, right? Because they don't have a direction in which they're trying to go. And so I walked into brownfield networks, and even the technology that we're looking at right now, it doesn't automate our entire estate of everything everywhere, because that would require, 5 more people on my team to do that. So we go after the low-hanging fruit and we say, okay, if we can understand the design, then we can automate all of the things about that one part. Even if it's just a part of a data center, that's still a design.
So when you talk about design, though, my answer would be, well, of course, the design is to move packets from A to B. So can you talk a little bit more about further talk further about what you mean by what the network was built to do, besides the simple answer of move packets A to B.
Yeah, so let's talk about like what I mean by a design.
Yeah.
Sure. So what I mean by design is you have a set of devices, right? We understand that concept. Mm-hmm. And we know what their role is generally. Like if you're building a data center, you know what a spine is, you know what a leaf is, or if you're doing a WAN network, the network engineer goes, I know what the purpose of this box is, right? And then they'll say, well, I know how they're physically connected. And they'll say, I know what kind of transceivers are used, right? So there's an aspect of the physical layer design that every design has. I refer to that as the topology. So when we talk about a design, then we have the devices, and then I have what are called, design services. So a topology represents the design service that every single network would have, right? Now, there's another concept, like you can say, my network has BGP. So that would be a design service, and there's elements of what makes BGP important into my design. And you could kind of abstractly think about any kind of service, whether it's a common networking problem, like multicast or BGP, or it could be something that's vendor-specific. Like, let's say you're using a vendor-specific technology and you wanted to represent that as a service so that you could configure it and then validate its operational state. So we had to come up with a way to represent anything, any network, any vendor, any criteria, not just data center or just WAN or just campus. We had to be able to have that level of flexibility.
But you have to scope it on some level, Jeremy. You can't model anything. You've got to bound it into some standard set of modules?
Well, that's what we do. Yeah. So that's what the design services are meant to do, right? So if you looked at, the network designs that we put together, and then we could say, well, there's these 4 or 5 design services, topology, obviously, VLANs, maybe BGP peering, maybe multicast, maybe PTP. That doesn't represent every little nook and cranny of a config. And it doesn't have to, because we're not trying to operationally check every nook and cranny, right? In the configs, there might be, these are my NTP servers, these are my DNS servers, We don't model that as part of the design, but it's part of the Jinja templates that make up the configs, right? So the point of that is we only go after the operational state that truly matters, and then maybe we grow that over time. So we don't, we had to take an approach that didn't require us to do all the things at the beginning. Okay. And that was a major, major decision point in our approach, so that we could, pick a slice of a data center, perhaps, and just kind of do that maybe just these 2 or 3 racks worth of services, and just kind of grow it. And that gave us the opportunity not to make an all or nothing, commitment, because in most of those cases, when you try to bite off too much of an elephant, the elephant sits on you and you die. And
when you say we took a slice of a data center, you're saying we're trying to sort of model out what the design of the slice of the data center is for?
Right. I mean, if we look at a data center and we say, well, in this data center, we have different kinds of services that are important to our line of business. We're not Google. We're not, Spotify. We have very specific things that run in our data centers. And so if we were to model the design of the network infrastructure and those devices just for that one important, service that helps run, the game of baseball, then we're not trying to do 20 racks. We might be trying to do the 3 or 4 racks that are important to that one service.
Okay, so this notion of design-driven network assurance is iterative at the outset.
Very much so, very much so. And what we kind of find out what's kind of interesting is that we will put something in the design, and then we'll kind of turn the crank, and then we'll get the operational state back, and then the operational state would be like, hey, there's something else going on here. And then we're like, oh, maybe we should add a little bit more to the design. Because a lot of times, I'm learning about the business of what we do, and there's infrastructure in there that I'm like, oh, well, what is that about? Maybe we'll kind of add that piece a little bit. And it is very, very iterative. Yeah.
Now, from the stage, you said that the design, maybe I misunderstood you, but it's not a bunch of YAML. In other words, how we're describing this design that's got switches and ports and interconnections and so on. It's not a bunch of YAML. What is it then?
Yeah. So the makeup of our approach is like a product. Somebody said, you have to approach network automation as a product, meaning, there's care and feeding and attention to the engineering aspects of it. And so we just decided we're going to write a system in Python, right? And we're going to represent the design The same way a software engineer would say, here's a software design toolkit, an SDK. Like say you're trying to build a Slack application. Slack will give you an SDK that says, oh, here's the widgets for a dropdown and a button, and you can compose an application using an SDK. We took the same approach. We said, okay, here's an SDK, and part of that SDK is, say, the precision time protocol module, or here's a SDK that is the topology module. Okay. And we can represent the design that is network device vendor independent in a way that the design says this is what the network is supposed to do. But when we go down to the low level touch the network pieces, that's where you're like, oh, I'm going to touch, an Arista device through its eAPI and through a Cisco NXOS through the NXOS. That level doesn't percolate into the designs. And that's a very critical thing, because if we have to do a network refresh and we have to swap vendors for whatever reason, it makes it much easier to say we're still doing the same design. Or if we have different ballparks that use different boxes for the same design, we can approach that kind of a problem.
But you're saying in your model, you've used Python to say, we represent a switch this way, we represent a port on that switch this way, we represent a transceiver that connects to that switch this way, and you've modeled all that out so that it can apply broadly.
Correct. Okay. Yep.
Is that your own model then, or is it based on some kind of industry standard? I say that loosely, knowing that I just kicked the hornet's nest.
Yeah. No, look, industry standards are great, when they work for you. But this type of approach doesn't lend itself well for a couple of different reasons. A lot of times, industry standard models are incomplete for the purposes that we require. And also, not every vendor that we use implements the same version of an industry standard if it involves an industry standard at all. Like you could say, well, if all of my products were using OpenConfig, gosh, that would be great. That's like saying, if all of my switches were from the same vendor, that would be great. And then you get cases where even you have vendors that are both using OpenConfig, just to pick on OpenConfig, they might be using different versions. And those versions, mean that the data model in itself is different. So a lot of people don't understand or trip over these nuances until you've done this 100 times. And so when I saw, OpenConfig, I'm just like, oh, well, it's just SNMP all over again. We're just going to end up with enterprise MIBs. And that's kind of what happened. So, So to answer your question, what I tried to do was create models that fit the services, the design services that we were trying to accomplish, not the very low-level device abstractions. And I try to talk about this in the presentation a little bit. Mm-hmm. And this is something that I learned along my way in vendor land, is that the abstractions are meaningful at the service level when you're doing a design. The abstractions at the device driver level are only meaningful when you're trying to implement something to talk to the device. And those two things should be separated, and there should not be any kind of what they call abstraction leak between the two, if at all possible.
Can you give an example of a service?
Well, yeah, like the PTP, for example, is a design service, okay, right? So I can say, on this interface, you're the grandmaster, or you are a slave, or you are a master. I can designate, in a port profile, which is how we kind of represent these relationships, and that allows the system to go, oh, I know this device is using PTP, therefore I know I should turn on the PTP service, for this device, which in turn then says, when we generate the configs, do the needful. And then when we generate the checks, we know, well, I know I need to generate PTP checks for this device or for the service. Those PTP checks are also vendor agnostic, meaning there's a data structure that represents these are the values of the check and the expected values that we want to see. It's the low-level device driver that turns that check into actual touch the device, interpret the data, and then respond back. And I do cover checks and how that works in my Nanog talk in a lot more detail, because that's a lot of concept and whatnot. So folks could check it out.
Yeah, we'll link that in the show notes.
Yeah.
Okay, so to speak to that low-level bit there, and you said there's two levels of abstractions. We don't want to leak between the two of them. What is that lower level abstraction they're using? Just a vendor-specific interface that they give you that you're hitting, like an API, or? Yeah,
I mean, APIs are great. You can choose whatever they give you. So, if I have to talk to an Arista device, I'll use the Arista eAPI. If I'm using a Cisco product and that Cisco product has an API, I will use it. In the case where I have to implement an automation around a product that doesn't have an API, could I choose to screen scrape? I could choose to do that. Could I choose to try to use SNMP to get the data out of it? I could choose to do that. But that low-level implementation detail is never surfaced up into the design. The design never says, oh, by the way, use SNMP to talk to me. I mean, that is the abstraction cutoff point, right? NetCAM, computer-aided manufacturing, that's where all of those low-level details are contained, and NetCAD is the computer-aided design, which that's where all the design elements are.
So NetCAD is that model. You've modeled the network using Python. You call that NetCAD, correct?
Yes. Yeah.
Okay.
Both NetCAD and NetCAM are both written in
both
Python.
written in Python. Okay.
That's right.
Okay.
Yeah.
All right. So
it's all Python.
NetCAD is the design, and then NetCAM is the way you sort of interact with the network and make sure things are working as they should?
Yes.
Okay, so that is the network assurance portion of the design-driven network assurance?
Well, I mean, they work in concert because, okay, so we talked about design, right? And, of course, we're driven because it's an automation, right? and we're talking about the network. Okay, we got that word. Okay, assurance, what does that mean, right? Well, to assure something to be operationally correct, you need to know what to expect, right? So the design tells us what to expect, right? The design says on this interface, it should be a 10 gig long-range optic. Now when I use NetCAM to pull that data, what do I see? Do I see a 10 gig optic or do I see, a 1 gig optic? And so that's kind of the easiest definition of assurance at kind of a very physical level, right? And the physical layer is often, ignored by automation systems like as a whole. And that's sad because if you can't get your physical layer right, nothing else is going to work. So that we started there. Like we literally started at solving that problem to make sure that when we had contractors coming in and they were plugging stuff in and cabling buildings or ballparks that, we made sure that physical layer, let's get that right before we try to say, why can't we run BGP, for example? So we did that.
You haven't said the word intent. Are you avoiding that on purpose? This feels like intent-based networking on some level, but you're saying design.
I'm saying design because I think people understand what the word design means, right? If you asked a network engineer, show me your design, they would show you a Visio diagram. And in some cases, they might show you, here's a spreadsheet that lists all my ports, what they do and their IPs and their VLANs. Like they would say, I have documentation that represents, the aspects of this network so that I can implement it. Mm-hmm. Intent has no meaning. Like it's a marketing term. I mean, it's a fun marketing term. Don't get me wrong. I mean, I think we like kicking that around, but people can't put specificity to that language, right? And so I think people will say, I know what a design is now, but how do you implement your design in a tool like this? That's the question people ask. And while I have chosen a certain implementation, it's almost immaterial. It's like, I could throw out this whole, toolkit, and because I'm the person that likes to do that. Just, that was a good learning experience. Let's try something else. And maybe buy a product if one existed that did this idea, then that would be great because I think this concept is kind of holding back network automation. The lack of a product like this, is holding people back because in some ways they're afraid to automate things, right? I don't want to automate this thing. Well, why is that? Well, I'm not sure if I broke the network. Okay. Well, if you have a system that says, well, if you do this design and it generates these configs, and it generates the checks so you didn't break the network, well, that's where we get into that aspect of the DevOps guys did the 10 deployments a day, and that was like the light bulb. They went, aha. Now we know why we want to do this, because now we feel safe about doing something that at high velocity and low risk. And that's when I'm trying to capture that lightning in the bottle with this type of idea.
There's another term you didn't say, which is source of truth. And the design also feels like you could term it source of truth. Is that fair or unfair?
Again, another kind of loaded term because everybody, looks at products, and they say, this product is my source of truth, and then some of us will say, well, that's really a system of record. And you get into this language. And I even was talking with, Karidi, he said something up on stage. He said, well, really your database is your source of truth. And I said to Karidi, I'm like, well, if you have the design, you could generate the database. And he's like, Right. So, a term that I learned years ago was, something you could programmatically reason about. A person in their mind can think about a problem. You can conceptualize, you can imagine, right? And turning that into, in my case, code that we could programmatically reason about is what is really capturing the design. Now, could I have done that as a series of YAML files? Do I see that in the market?
Yeah.
Yeah, I do. I mean, I look at something like Arista AVD, and they're taking the idea of what I'm talking about, and their implementation uses YAML to capture design elements. And that's, it's a path fraught with peril, but it does capture the idea, right? It's not an implementation choice I would have made, but I think they're following the same, the kind of the conceptual idea. And I'm seeing more and more folks saying, well, how do I represent a design so I can get something out of it? In the case of Arista AVD, they're like, from these design files, I can generate documentation, which I think is awesome. I think that's a great concept. And then they take those files and they generate Ansible playbooks because that was how they want to implement the NetCAM part of my idea. Or I don't want to say my idea, but this concept, right?
Approach,
so
yeah.
I try not to get hung up on how did I implement this thing, because that's not the message I'm trying to get out. I think that rather than looking at network automation as config automation problems and troubleshooting problems and, these kind of piecemeal approaches, I'm trying to, as Kriti said, look at a holistic view, right? Because there's a benefit that comes out of that until you see it, most people don't know it because they've never seen anything like that, right?
Can I try to read back what I get from this? So at the high level, what you're trying to do is the design is a set of outcomes this network should deliver. And then there's another portion of that, maybe the NetCAM part of that is giving me the assurance that I am actually getting these outcomes that I had designed the network for.
That's right. And it will tell you, if you're not, exactly what went wrong. So we can pinpoint in and say, oh, we're not seeing an optic on this port. And then somebody might say, but I plugged one in. I'm like, well, can you push it a little bit harder? And then they go, oh, it just clicked. That's the physical level kind of a problem.
Right.
Or if we're like looking at the topology convergence of the PTP protocol, it's like, do we see the grandmaster on a port that we know that should be on a grandmaster port? And if the answer is no, then, we can see, okay, well, why is that? We'll do a little bit more troubleshooting, which maybe that's not automated. Somebody has to go look at it and says, oh, we didn't turn it on. Sorry. It's like, so I think you've represented the idea correctly and described it correctly, but they work together, right? What was an interesting outcome of this was, and again, looking at brownfield, we said, well, what if we designed part of the network, but did nothing at all with config? Nothing at all. We don't care, right? And so we were actually able to create this design and then measure the state of the network to that design. And then once we've captured that, then we could go back and regenerate the configs. And so this way we could be like, okay, all the configs that were on the box, we could probably throw them out because, they're like, grown over time and they're not consistent or whatever. But it's almost this really interesting, brownfield, bring you into automation pattern that we just kind of tripped over along the way. And I'm like, that is really cool.
Wait, I think you lost me for a second there. Okay, so we build a design, and then you say, and then we don't going to do anything about config. And so in the brownfield setting, what you're doing is looking at the configs that are in the network now, comparing them to the design, and then making, is there anything here we can still use? Is it that kind of thing?
So it's like this, like as I'm building a design for part of the network or whatnot, and I would talk to the network engineers. I'm like, all right, what are we doing here? Oh, it's these boxes and they're connected on these interfaces and they have this, physical layer, right? And then I go like, okay, just starting at the physical layer. Like I can put that into the design, run the checks. And I say, yep, what you told me is correct. I see that, I see those optics. And they're like, okay, let's do the next thing. All right, well, what's the VLAN topology, supposed to be like? Okay, I'm going to represent the VLAN topology in design. Like these ports should have these VLANs. These should be on these ports, whatever. And then I can say, okay, generate the checks. Is that operationally true, right? And so we can kind of iteratively go through that process. Now, once we have the design built, and I have that, we'll call it a data model of the design, something I could programmatically reason about, then I can say, okay, now that I have all this data, I could then create a set of Jinja templates to generate the configs as they should be. And then if we wanted to like diff the two, it wouldn't be very meaningful because now we're saying, okay, well, now we have a clean set of configs compared to there might be stuff on this configs that is just dead config and it's been laying around like, and this is an interesting way to bridge that divide between those two things. It's a learning experience. It's a discovery process. It brings you on the path of, design-driven network assurance. And we don't have to worry about any kind of conflict with, we're not changing the network. We're not configuring it. And when I learned, when I started teaching people network automation, I said, start with read-only stuff. Right. This is an example of that at a massive scale. It's like there's no risk to the network because we're not changing it, but we're discovering its design. We're kind of archaeologically discovering the design so that as we move forward, now we have junior network engineers who want to do something. They can now make a change to the design, and we can go forward in kind of a safe, sane manner.
But this is the thing I was missing. My brain still has a pattern from back in the days of looking at a configuration on a device to see how it is behaving, when in fact, that's not how you tell how a box is behaving. It may or may not be behaving the way it was configured because reasons. There's a lot of reasons why you can have exceptions to what the intended configuration has told that box to be doing. So what you're doing is you don't care what the configuration is. You're looking at how is the box actually behaving? Show me port state, show me VLAN, show me all these things, concluding exactly how the box is operating, what its actual operational state is, comparing that to the design, and then going from there.
Yeah, I mean, a lot of times when we do this discovery, we do look at the configs. We're like, okay, I can see that it is configured this way. Yeah. But when we go into the design, we say, okay, well, I saw this, and I put it into the design, and then you could even have the system generate reports, and you show those reports to the network engineer. He's like, oh, yeah, we're not using that VLAN anymore. Yeah, we did that for some kind of testing 2 years ago. We could get rid of that. And then so we take it out of the design. And so then when we go back and maybe generate the configs again, all that's gone.
So I think it's important to highlight here, you're talking about working in a brownfield environment, which is real gnarly for network automation to get wrapped up in because there's so much stuff in there and you may not be confident. You may not have the assurance that if I automate some change, suddenly I'm not getting the outcomes that I wanted anymore. You're starting in brownfield and saying, let's see if it's actually doing what it's supposed to do and going from there.
Yeah, we do both. We do both brownfield and we have new projects and we have refreshes, which I guess you would call brownfields. We have to deal with this thing called the real world.
Right. That's the thing, because I mean, a lot of people, a lot of vendors that you talk to will say, in this new network that you're going to build, you do it this way and then you can automate and so on. And that's fine for that new network, but you also got to live with the network you have. So
not the network you wish you had.
Right. The fact that you can apply this to brownfield, I think, is important.
It is critical, actually. It's really kind of crucial. One of the things that I learned, from my vendor days is the fact that you have a really awesome product that only works in greenfield is, it prevents people from using it. And that's, part of the story here is like, why haven't we seen the adoption of network automation? To some people, network automation means product. It doesn't mean I'm going to write a Python script. It doesn't mean I'm going to use Ansible or NetBox. It means like I am going to buy Cisco NSO or I'm going to buy, Arista CPU or whatever. To them, automation is a product. And then you're like, well, why is it they can't even use those products or what are the friction points of that? If you don't have a means to address a brownfield environment in some way, not holistically, not 100%, maybe even only 20%. Like maybe the only thing you want to do is validate the physical layer, which includes optic transceiver, levels, for example, which are super important. And you stop there. You're winning.
Jeremy, you've built a custom system here for MLB. It's in Python. You told us not everybody's going to be a software developer that's going to write a network automation platform from the ground up in Python, especially someone like you who's benefited from lots of years of experience in vendor land. You had your own startup. You got tons of experience that most people don't. How do they apply what you've learned and what you've built to their environments?
Yeah, my best advice is having seen the thing that you want, go to your vendors. Make them do this thing. Even if it's like vendor by vendor, if you were an Arista customer and you're like, hey man, I saw this thing Jeremy was doing and these concepts are awesome and your product is good, but can you make it do that? Because now I understand the benefit of that thing and I want that. Go to your vendors. Or if you find a multi-vendor company, like there's many here that I've seen that are these workflow orchestration systems or even companies that are focused on one element, like say observability or just configuration management. It's like, go to them and say, look, I know that you just do X, but let me represent my network as a design, not like, click here, touch this 5 things. And every time something changes in my network, I have to like click 30,000 buttons, like take the idea and drive your vendors relentlessly towards this kind of design principle. I know that it works. Right? I'm not saying I have all the answers. I have a philosophy about this. You know, there is the right now answer, which is great. Like 10 years ago, I was doing Ansible, and it was the right now answer. And as I've gone further, I'm trying to get closer and closer to the right answer. There's the right now answer. There's the right answer. Is what I'm doing the right answer? It's the rightest answer nowiest that I have that actually achieves benefit at a business level. Like if I put in the work, that the aha to cha-ching and the oh crap to all clear that I talked about can manifest in a way that before it couldn't.
Are there some shops that should be taking your approach? I don't mean philosophically, but I mean the build it internally. We're going to build it in Python. We're going to build it and go whatever it is, but it makes sense for this sort of company to stand up their own network automation.
Oh, yeah, for sure. I mean, you'll see that with the service providers 100%. I mean, Chris Cummings did a presentation, which was exactly this. I mean, he did exactly this thing, and he's got a team of 20 software engineers, and they're a service provider. And in that case, the network is their revenue, right? Revenue drives their business. They will invest, they will buy, they will borrow, they will build. They'll buy product like NSO. They'll borrow from the open source like Ansible, and then they'll build their own. Like that's a very sane approach to network automation. Buy what you can, if you've got the budget, buy what you can, borrow what you can, and build only what you must. Only what you must. And I when I was at Juniper, we saw all the service providers had their own approach. They had whole teams of software developers building these things. Right. I mean, if you wanted to, and if you were a vendor trying to break in, that was like a block. It's like, oh no, our network management only works with Cisco. Sorry, Juniper. It's great and all, but it'll be 8 months and we're just not interested. Like that in itself becomes an interesting problem. So, I live in the world of a large-ish enterprise, and that's such an underserved market for this problem. And there's so much, demand, I think, pent up for the capability and the need for products like this. They just don't exist. They just don't exist in the marketplace. Not yet. And so that's why I say drive your vendors relentlessly. Or, I don't know. That's why I just drive them relentlessly.
So you have developed internally this NetCAD, NetCAM approach. You've built it around Python. Does this mean you now have essentially a software product to maintain internally?
Yes. Basically. I mean, the short answer is yes, kind of. I mean, like anything, that's an internal thing. It's, it's something that you work on constantly. I kind of quote unquote have a roadmap and feature requests and, I have Jira and, but what's really fascinating actually about this is when we used this tech with, say, our ballpark folks, and they saw it in action because they are the key beneficiaries. They started making suggestions. They said, well, I see that you've represented all of our devices in your design and all of our IP addresses. Could you automate the ping sweep to make sure that all of these things are pinged and that the MAC addresses are landing on the ports that, we expect them to be? And I'm like, wow, that's a really cool idea. And I'm like, how'd you come up with that idea? He's like, because we do that manually, dude. And it would be awesome if we could just click a button and it'd be done. And I'm like, that's a great idea. So I don't come up with all the great ideas. I'm like, that's impossible. Sure. But what's really fun is when we work with the stakeholders of the network, they're like, this is my problem. Can you help through this technology? Save us. And he came up with like 2 or 3 really great ideas. And it was so awesome to see that level of cooperation between teams at a network automation level you never see that. I've never in my life seen that ever.
I guess I bring that up, though, about you now have a software product to maintain because there are network engineers out there who are kind of repulsed by the notion of software development. So I guess if I'm thinking about your approach, do I also have to be open to the idea of doing something more software development-ish with my job?
Yeah. So, I mean, again, the fact that I chose this implementation decision, like I chose to do it in Python for reasons, is a choice that I made. If there was literally a CAD system of my dreams, like drag and drop and, click this and do that. And maybe even those tools needed a sprinkling of some kind of programming. Like we see this in like other market segments all the time, like Zapier or Workata or, those types of things. Like here's this really amazing workflow engine, but you might have to sprinkle in a little bit of JavaScript. Like if we could get to that level in the industry, then we're kind of achieving what I think is rational. I'm a network engineer. I have domain expertise. I have a tool that gives me superhuman capabilities. That's my Iron Man suit analogy that I always talk about. And maybe I need to know just enough Python to use those tools more effectively. That is teaching somebody who has domain expertise how to use another tool, which is a little bit of Python. I think that it's irrational at this point to say network engineers have to become software engineers, because network engineers take 5 years to become senior network engineers. And for somebody to develop the kind of software that I'm talking about, you have to do another 5 years at least. I mean, and nobody is going to do that, I don't think. Not in this generation that we're talking about.
Uh-huh.
Yeah. I don't know. Maybe I'm being grumpy a little bit.
I don't think you're being grumpy. I think you're being practical. I mean, I went to school for 4 years to get a computer science degree, and that was a lot of programming in a computer lab to get to the proficiency where I could, yes, sir, you've done the computer science program. I've never used it in anger, as it turned out. Never been a programmer professionally, but it certainly made it a lot easier to write scripts and all of that. I want to go back to a point you were making about relentlessly harass your vendors to build a product that uses these concepts that you're describing. One of the challenges you face is multi-vendor. So we'd be asking, who are we asking? The network equipment manufacturers to build this tool for us? Or a vendor who kind of sits, they don't make network equipment, but they make automation tooling to support your multi-vendor environment?
Yeah, why the tyranny of war? Like all of them, honestly. I mean, it's not going to be like a switch in the industry that says, oh, now we have this, right? Would it be great if, there was I like to use the term vendor inclusive, technology company that could react very agile to say, oh, I know we don't do vendor X, but we could add vendor, X real quickly. It'd be great, but, there are, shops that are like, well, we use, vendor A for this part of our network, and even if they just had a tool that followed this design philosophy just for that part of the network, that's progress. That's progress. I think the more we see this idea percolate throughout vendors, will drive, vendor inclusive other software companies. I mean, there are many software companies in that, in the area here, and many of them could do this idea, but it comes at a cost. I mean, this is not easy. I've learned this from my vendor days that it's not a cheap endeavor to do it as an independent VAR or system, a software company, and the VCs just don't care. Like, it's not a market segment that they want to put money into. I mean, it's like they care about whatever AI. If you can you're like AI-driven, design-driven network assurance, sure, okay.
Yeah.
Well, design-driven network assurance.ai, sure, whatever. Then you'll get money. But I think that's really the challenge. Is part of what's holding this back is there's not enough care to solve this problem, and that word translates to VCs, or could translate to your leadership, or could translate to the people on your team. There has to be all these people caring about solving this problem to really move it. And if all we can do right now is yell at our vendors to say, build me a product that follows this design idea that Jeremy showed you, so you don't have to have me write your requirements for you. Like, tell me, Mr. Customer, what are your use cases, so I can build a product. Like, it's like they can now point to this thing and they're like, that idea, do that better than what he's doing because he's one guy.
So you reminded me, the way you opened your presentation today, you said everybody's got to be on board. Everybody's got to be invested in this, up and down, business, all your IT team, everybody's got to be on board. How did you convince folks within MLB that this is a thing you got to get behind?
Yeah. Well, that took me a couple of years to unravel. It's a fascinating question. What I learned about network automation is that people don't care about you, the network engineer. They don't care if you have tools to help you do your job better. I mean, they care about you maybe, but I mean, I don't mean to be like, totally. But it doesn't affect the business. They really don't. They care about outcomes, right? And so one of the very earliest projects that I did was building a chat ops system so that people who were outside of the networking team could get information about the network that they wanted or make subtle changes, well-defined changes. And really what that was is like people wanted to have a self-service experience so they can have that instant gratification. And at the same time, it indirectly benefited the networking team so they didn't have to like service a ticket. But when people started to realize that automation could help operational efficiency and allow the people who needed the network to do their job. They could go from aha to cha-ching or oh crap to all clear. Then they're like, okay, I get it. They had to see a value that touched the stakeholder of the network, not the networking team themselves. Now, the networking team themselves they're like giddy about this because they're like, we're like a very small group of people. We have to do all the things. So anything that you can do to draw down our operational load is awesome, which is a concept that I learned from the Phoenix project that John Wills talked about, like creating capacity. So once other teams started seeing the benefit, then they were like a 5-year-old with ice cream. They're like, I want more. I want a different flavor. I want cake with it. Like, can you show up with a bouncy castle with it? It's like, but it took years really to develop, that level of engagement with different aspects of the business. It wasn't just ballpark, because I talk about them because we just did stuff, but the security team, the IT team, the InfoSec team, all the teams, like, and then once one team started hearing about it, they're like, well, I want in, like, I want a chat ops thing. Like, I want to be able to like automate power, through chat ops, and, like just really amazing ideas came up from the different aspects of our business. And from my sales days, I loved understanding the business of what people did, not just like, this is the network, here's a box with ports,
This is fascinating, Jeremy, because I would have assumed you got hired to do this essentially, and that's not what you're telling me.
I was. I mean, what was brilliant was the reason why I came to baseball was because there were leaders there at the highest level that said, we do not have network automation at all. We have nothing. We have great cloud stuff. We have great, DevOpsy stuff, but the network, we have nothing. So make it better. And I call that journey the journey of caveman to spaceman, right? Like we're in a cave, we're banging rocks together to try to make fire, and are we spacemen? We are not. But we're out of the cave. I think we've got, I don't want to say self-driving cars, but we're getting there. We're really getting there. But what was fascinating was I had this really amazing air cover from leadership. They're like, make it better. We're hiring you because you know what you're talking about, and we believe in you. And that was so special to me. Like, I mean, that's really,
that air cover
I break up about it because, I mean, when somebody believes in you to the degree where they're just like, you come up with a strategy, you come up with a tech, but know that this is the network that you have to work with. This is the constraints of the team that you're working with. They're not programmers. You're not going to get one more programmer for a while. It's like, know that. And I said, that's cool.
And you still had convincing to do, though, even with that backdrop, even with that.
Oh, yeah. I mean, I had to start with, how do we take a group of people who are like CLI out of my cold dead hands, not going to like, they're like, network automation is going to take my job away. How do we transform just internally that group's attitude or approach or comfort level before I could even reach outside, like, and work with the other teams? Like, that was like 2 years worth of work. And it wasn't one for the direct leadership of the network infrastructure team at the time. It would never have happened. So that's what I'm talking about when we talk about people have to care up and down. Like, it takes a long time to do that. But when it happens, it is special. It is truly special.
So I want to come back to something. Let's say you've got a network engineering team and maybe some leadership one level above them who are, yes, we see the value in automation, we want to go forward. A way to start that is to look at a project that you could do that doesn't just benefit the network team. It will have some larger business outcome as a project to maybe get behind, because that's when you will get additional looks from the other side of the business or other IT departments or whatever, because you can demonstrate this value to them that has a business outcome, be that financial or otherwise, velocity, whatever. Absolutely.
And sometimes it's not as hard as I would make it sound. A lot of times it's actually just telling the story. Right. And I did that, like the lead in of my presentation where I talked about, everything that we do is about the fan experience. And like, well, how did I tie back network engineering to the fan experience? And yet I did. Right.
That's a good story.
Yeah. I mean, but I have years of selling experience to know how to do that. I think maybe, one of the things NAF could do is help, network engineers and their leadership, maybe their leadership do that. Because I think that's a big part of, again, why we're not moving forward. But to go back and answer the question, it's like, if somebody says, I've got this automation, I've got this project that network has to complete, and we want to use automation to do it, well, figure out who it's going to touch outside of the networking team. Like, and if you can't find that answer, it doesn't mean it's not valuable.
Sure.
But it might not be the right one to go after. Or it might. Like, for example, we had a problem called upgrading the network, and we have all these different vendors and we have all this different software, and we need to do that. And that's that's a job that network engineers need to do. Now, I will buy a product to do that. Finding a good product to do that takes time. Vetting that vendor, going through the process, blah, blah, blah. Am I going to write the code to automate a multi-vendor network? Because, somebody's like, oh, wow, that's a great use case of network automation. I'm like, no, it isn't. I mean, not like DIY, because I've done that. I've tried to do that just for Juniper. And I'm like, oh, that's terrible. I don't want to do that again. So it's all about, knowing strategically where do you want to put the wood behind the arrow. Buy what you can. Build only what you must.
Mm-hmm.
Jeremy, the code that you've written for MLB, that is all proprietary MLB. None of this is open source or anything, right?
Correct. Yeah.
Okay.
I mean, it would be, I think, a fool's errand for multiple reasons for me to try to attempt that. I mean, don't get me wrong. I love doing community stuff. I mean, I like building stuff that I can put in the open source. But if I were to do that, it would require a commitment level that far exceeds probably the cycles I have in my brain. It would really take a village to do it. And I'm not really sure that's a rational thing to try to do. Yeah. I mean, again, I'm really truly evangelizing a technique here or a concept. I mean,
principles.
All of this work. Now we're benefiting it because I'm there and I can do this and, blah, blah, blah. But ultimately, if I do nothing, quote, in the open source other than to evangelize a concept that drives real commercial product, which I would then benefit from, because then I would have to build this thing and maintain and support it, and I could do something else. In a heartbeat, man. That would be awesome if that were true. Now, do I think that's going to happen? I mean, a boy can dream. But,
Now, Jeremy, we're at AutoCon 0 here in Denver. The Network Automation Forum is going to be publishing all the talks. I assume that they're going to go out on YouTube. If you're listening to this podcast and you want to see Jeremy's presentation from today, go to networkautomation.forum. I know they got an email list. There's also a Slack group you can sign up for, and you can stay tuned for when all those presentations are going to be released. Now, Jeremy, you said you also had a related presentation at NANOG?
Yes. I have a related presentation on NANOG 88.
Okay.
Back in the summer of this year.
And NANOG definitely publishes all their stuff on YouTube. So if you go to YouTube and look up NANOG, North American Network Operators Group, NANOG, and look for 88, conference number 88, all the talks will be there, including Jeremy's. And Jeremy, where else can people keep up with you? You got a blog, social media?
I could do better. But you could find me on what is now X, but I am also on Mastodon. So yeah, definitely. Oh, and of course, LinkedIn. You can always find me there. Yeah.
Well, Jeremy Schulman, thank you very much for joining us today on Packet Pushers Heavy Networking. If you're out there listening, you can find this and all of our other fine free technical podcasts, along with our community blog, newsletters, and more. It's all at packetpushers.net. We have a Slack group as well. Over 2,500 engineers are in there from all around the world, chatting about networking, cloud, and other things. You got an idea, you got something you want to float, you got a problem you're trying to solve with, I don't know, your Meraki box and need a recommendation from someone about a way to solve this problem. Just go in there and post it to general and see what people have to say. You're definitely going to get feedback from lots of folks, and it's all free. And you can, again, find all that at packetpushers.net. We make it easy to find all those resources. If you want to follow us on the socials, LinkedIn is the best place for us these days. And last but not least, remember that too much networking would never be enough.